Hello again. Uh, Today I wanted to show off a cam template I made for helping with quoting. It's going to be real quick and dirty. I know a lot of the times as programmers we want to optimize our toolpaths and put down the best strategies that we can so our machine runs best and we get the best cycle times. But for quoting purposes, you really don't want to take the whole time, especially if you don't already have the job, and really fine tune all of your toolpaths. And sometimes you don't even want to mess around with putting semi-good toolpaths on it and having to click on geometry. So I made this automated cam template, no matter what the part, that will automatically generate some toolpaths on there, give you a rough estimate, and then it would be on you to obviously look at the customer provided print, see if there's any tolerances that you need to be mindful of, some surface finish requirements, any extra processing, to use that knowledge and add to your quote where necessary. But it'll just give you some estimated cycle times pretty quickly. So I have this part sitting here. You can see there's quite a few pockets in here, some holes that are different style, some maybe taps, some reams, counter bores, a lot of different stuff you'd have to pick through. We want to have a stock body. Now this one's pretty square. There's no funny profile to it. Doesn't look like there's any sort of large burnouts. We could just in our cam setup do a relative size box, and it would probably want to cut these areas out. Otherwise, you could make a quick burnout profile, especially if these were getting burned in. So since we have this body in here, I'll make that as a component. Then I'll make a new dummy one, put a sketch on the bottom, project that face, finish my sketch. And I'll pull that up to this face. So now I have a second burnout body with those cutouts in there, and it'll avoid that. Wasn't necessary, but just to keep the toolpaths from trying to do those at all. Then we can hop back over to the manufacturer, create our setup, and we'll go through like we've shown before, Z and X. Pick our body, which is in the window. Then in the stock, we'll drop down to from solid, expand our models tree, and pick that component 2 stock that we created. Now once I'm in here, I don't have any toolpaths. I can't expand this setup folder. I'm just going to right click, create from template, and use this RFQ. And once that's done, you'll see all these toolpaths populate. And there's no good toolpaths right now, so they're all red. So I'll just highlight setup and hit generate. You'll see them start going. If your browser is kind of shortened, which it probably is by default, looks something like that, you can either pull this out and watch the progress bars over here, or you can click on this task manager under the manage and just watch and see when all your toolpaths done. Most of them generate fairly quickly. One that doesn't is this 3D adaptive clearing, because it does look at shapes and wants to walk up fillets, and if there was a ramp, it's going to take those small steps into account, so that one takes the longest to generate. But these other ones typically do get processed fairly quickly. So I'll fast forward the video until they're all done and then go through them. Okay, so as we can see, they're done generated. The scallop failed, and we'll look into why. The longest one that it took to generate was this 3D adaptive. If we view the log, we can see it took 797 seconds, a little over 10 minutes. And with the bigger part and more features there are, that one's going to take a while. But we can see that it roughed down at all the levels, down in this pocket here, and went down into there as deep as it could, came up, hit that level. So, I mean, it roughed out everything. This is another version of pocketing, more like a Z level. We could use that as a time. Horizontals quickly hitting all the flats, finishing the bottoms, everything. This is the same version of of this tool path, but with a bigger tool. So if it was a much bigger part and or a larger pocket on a larger part, we would probably use an indexable and clear out those pockets. We probably wouldn't use it on this part, so for this purposes we can just blow that one away. Same thing, this is another finished flats with a 2-inch indexable. We probably wouldn't use that on this size part and these size pockets, so we'll blow that away and not use that in our time. This contour makes step downs. It's meant to not do fine step downs. It's a 3D contour meant for finishing high slope areas. I got the step down set pretty high, but it still generates paths more than I'd like to. But for quick and dirty numbers, it'll work. See, it makes one pass in this depth, one pass there, multiple down these walls. Like I said, it's good for a quick number. This scallop, I added the note to this, and it's meant for doing fillets or like round shapes. We don't have any on this part, which is why it failed to generate. If we look in here, I have it defined to not hit a certain degree, so no flats and no vertical walls, and it doesn't see anything where it's going to fit, so we can delete that because there's nothing on the part for that. This contour here is meant for steep walls with shape on them, like a steep ramp. I added that note to it, and since we don't have anything, we don't have like a ramp breaking out through or like a slug knockout, so we probably won't use that either. And the same thing for this parallel. Here you can see all the paths it generated. It's just basically trying to knock the edge off of everything. It's not actually, all these little blue lines, it's not actually cutting on any sort of shape. So it looks like it's trying to hit the fillets down here. But that also is intended for 3D shapes of low slope or shallow ramps. And we don't have any in this part either. So we're going to delete that. And then a drill that will drill any size hole from 0.1 inch to 6 inches. And the feed rate on it is fairly slow here. We drill faster than that, we bore faster than that, we tap faster, but to get an average of having to go and qualify holes or ream them and multiple processes on a single hole, I kind of went to this lower feed rate to have a guesstimate of, okay, some holes are going to have multiple processes, so they'll be drilling and chamfering and tapping, or drilling and qualifying and reaming. So that slow feed rate is to try to accommodate that estimated time. So once we have this roughing and the finishing bottoms and the walls and some drilling operations, we can just highlight setup, right click, machining time, and we have an approximate time for what these tool paths are going to take. After that, it'll be some judgment calls, like I said, referring to the customer print on tolerancing, surface finishes, and extra operations on the part. Hope this is a help and time saving. See you next time.